Okay, so for the final solution I'm giving today, I've jumped forward again in the problem set to the Diffie-Hellman key exchange. This is something that I know was difficult when we first introduced it, and that was the better part of a month ago. So I really want to dig in with the idea of what's going on here and what I'm asking you to do. So the setup of this problem states, perform the Diffie-Hellman key exchange with Octavia using the primitive root 2 modulo 101. Octavia sends you the number 75. Your secret exponent is 7. Calculate the number that you would transmit to Octavia and calculate the shared secret that you have with her. So what I need you to remember for this problem is that the Diffie-Hellman key exchange is a way of using modular arithmetic to make a number that only you and Octavia can know. In order to perform this calculation, the both of you need to agree on a modulus. So here I've just told you it's going to be 101. And you also want to have a primitive root to that modulus. So here I've just chosen 2. In the course of the exchange, you will have a secret exponent that you do not share with anyone, not even Agent Octavia as it was. So here I've given it as 2. Octavia has her own exponent that we don't get to know for this problem. So Octavia has sent us the number 75. That's not a random number. That's the primitive root 2 that both you and Octavia agreed on raised to the power of e, which is Octavia's secret exponent, and we don't get to know what that number is. We just know that 2 to the power e is 75 modulo 101. You can go back to the earlier slides to review the ideas for the Diffie-Hellman key exchange, but the gist of it is that working in modular arithmetic, it is very difficult to undo this kind of exponentiation, and that's where the secrecy comes in for this. So we are going to mirror what Octavia has already done. We need to calculate 2 to the power 7 modulo 101. And let's see now. Yes, so I've got 27 as that. So 2 to the power 7 is 128. Mod out by 101, we get 27. This is the number that we share to Octavia that does not give away our secret exponent. So that's part 1 of the question right there. This is the number we calculate. Now, because Octavia knows her secret exponent, she's the one who came up with it. And because you know your secret exponent, because I told you it's going to be 7, both you and Octavia can calculate the same formula. So on Octavia's end, she will take 27, which is the number you sent her, and raise it to the power of this exponent that we don't know. On our end, we'll take the 75 that Octavia sent us and raise it to the power 7, which we can do because we know our secret exponent is 7. Both of these formulas will end up producing the same residue, but you and Octavia are the only people that have enough information to calculate that formula. And in the end, this ends up becoming 98. Typo. This should be modulo 101. So the resulting secret, your shared secret, will be a residue mod 101. So I'll correct that in the slides that I upload. Okay, so we are more than halfway through the solutions to the problem set. I'm going to have the final batch of test answers up tomorrow, and then I'm going to release the actual exam problems as a PDF on our Moodle page. So as you're watching these solution videos, if there's still something that doesn't make sense, or if you have any questions about the steps that I'm doing, the things that I expect of you, please send me an email and I will try to answer those as soon as possible. Otherwise, I will see you again tomorrow for wrapping up the final bit of continued fractions and the solutions to the last bunch of test problems. I'll see you then.